My name is Anatoly, and today I'm going to share some of our experience in online banking systems and some other stuff. So, but first of all, I have to say that I'm honored to speak on behalf of the Kaspersky application security team. This story started more than 8 years ago, so I joined the team about 5 years ago or a bit more. And for 5 years, we've analyzed hundreds of web applications. Practically every third was banking application, then dozens of mobile applications, so other research stuff, CTFs. We make CTFs, we play CTFs, we do bug bounties, so we have some experience. So, what should I mention? That I ain't gonna talk only about banking security, because usually it's Java plus Oracle, so there is a lack of interesting cases there. And also I really like to share the only interesting cases in our daily work, so I'll tell you about web application security, mobile payment systems, online shops, etc., etc. So there will be no dry enumeration of WASP top 10, nothing about banking fraud, ATM hacking, networking, malware, or physical money robbery. So, but first of all, I just have to ask some of you, does any one of you uses internet banking systems? Is there anyone? All right, so I think I don't need to explain this slide. So every one of you uses internet banking, maybe mobile banking, Google, Apple Pay. Maybe you in Romania can transfer money using SMS. So let's just skip to the concept of the report. So I'll just name some vulnerability, and we'll take a look at 3 cases. The first case is a good case when everything seems to be fine. There is no vulnerability, but there is still some problem, something went wrong, there is some side channel, so the vulnerability will exist. In the bad case, it's not fine, but the developer at least could have tried to avoid the vulnerability. In the ugly case, the developer totally ruined the application security. Just please pay attention, I say developer, not the customer. Because usually our customers, they hire third-party developers to do their stuff, and they hire us to do our work. And there will be the second part, there will be kind of a tale of stubbornness that meets curiosity. So let's move on. The first vulnerability, it's user enumeration. I think that you all know what is it. It happens when an attacker can determine user existence on the system. So let's imagine that the developer made everything well. There is no such vulnerability on the system. But when we try to put the name of our customer on the Google using pastebin, we found some cards, some card holders, and all the information about them. So we thought that maybe some of the employees, he thought that it will be a good idea to share this data using pastebin. So you can never say where will be the problem. The typical bad case, it's user enumeration using brute force attack. So they have only to say that any system should only provide one error, that username is incorrect. Even if the attacker is already logged, he should not know about this. The ugly case, this was very strange. It happened with another vulnerability of insecure direct object reference. And it happened so that the user ID was just a number, and it was incremental, and just iterating this number from 0 to tab, we not only enumerated users and we got the existence of the user, but also we got the mobile number. So just to protect from user enumeration, from brute force attack, the developers they usually use capture. I think everyone knows what's capture. And you can implement capture well, but there are dozens of capture solvers. So you have to keep in mind it. And sometimes you can implement capture in the wrong way. For example, there can be a capture you use. For example, there is some session parameter, and when we check the capture, this parameter is not being unset. So to reuse this capture, we just block all other requests to capture. In this case, we need to recognize it only once, and then provide our attack. And the ugly case, the first one is when the developer he decided to send a capture value to the client, and also there is something like capture use because we have an ID of the capture. But the other one was just generating capture on the client. But if you will look closer on this example, you'll understand that this guy, he earns money for every line of code. So we can't judge him. Okay, so let's say that there was capture in your system, but it was bypassed. And you have some monitoring system, and it tells you that some user is being attacked in some way of brute forcing. So what you will do, I think that you will try to lock the IP of attacker, right? But you have to keep in mind that there are some other proxies, anonymizers, that there is Tor, and that you have to restrict all traffic from exit Tor nodes, because nothing good comes from Tor. In the bad case, the developer decided to lock user but temporary. But if there is user enumeration, we can call denial of service for the whole bank. And this will cause some problems. But in the ugly case, the lock is permanent. And in this case, bank just loses its customers. So keep in mind, we do not lock user accounts, we lock attacker by IP address. The final solution is two-factor authentication. So one of them is one-time passwords, sometimes it's tokens, and in the good case, it can be all right, but if there is a victim and the GSM traffic can be intercepted, or for example, I can negotiate with some employee from mobile network and he will duplicate me SIM card, or he will just give me the one-time password. Or we can just steal the mobile, we can steal the token. The mobile can be compromised. Also, just you remember about social engineering. But the bad case, the really bad case, is that there can be race condition. If you've ever seen it, in this case, one-time password, it becomes many-time password. And it allows us to attempt multiple login, or if we are working with a transaction, we can make multiple transactions. And in some other ways, there can be item dupe or multiplication. So this is a screenshot from Lineage. Once upon a time, we had this bad case. So there is a mobile operator, and it's his website. We have some interesting features there. We can manage our subscriptions. We can look at our calls. We can transfer some money, and we also have a blacklist. So the blacklist is such a thing that you add a number here, and you won't get SMS or calls on your mobile phone. But there were a couple of security flaws. So the first one was XSS, and the second one was self-blacklisting. So I think that if you know what cross-site scripting is, you already guess that we just enable subscription using the XSS. We add the number of the victim into blacklist, so the victim will not get the one-time password. But this one-time password is viewed in the blacklist in the web application. So we just get it from here, we provide the subscription payment, and we get some money. So this one was very strange, and actually this was an investigation because the mobile operator, he couldn't understand how did it work. And the ugly way of using one-time passwords is to forget to check them. So in this case there was a parameter authentication mode, and it told the server which time of two-factor authentication will be used. For example, here it is RSA token. But let's say I'll send something like empty or something that will be absent on the system. And if the server doesn't know this type of authentication, it will just skip this step. The other one case was with this pretty card. So we get from the system these coordinates, let's say D3, it will be L, and then we send on the system the value of the coordinate. So it works fine until you think that an attacker cannot eavesdrop your traffic. If he can, then he will get this whole card. But anyway, the logic was practically like this. So for example, if we request for the map, there will be a parameter in the session, but if there is no request for the map, we just send credentials, skipping this step. So it will just check credentials, and we will pass the second authentication step. And I think that this case for currency exchange is well known to your country. As for our country and some others, so the good case was that there was this component to exchange currencies in your banking account, but there was a default in the country, and this component was not up to date. So with every exchange, bank just lost money. I don't think that this is a developer's fault, but still. The bad case is math round vulnerability. Have any one of you heard about this? All right, so I'll explain. So let's say that there is a customer, there is a bank, and there is some currency. So you can buy $1 from the bank using with 33 of currency, and you can sell it using and you'll get 30 currency. And there is a casual math round, not floor, but just casual math round. So it works fine until it comes to small numbers. So look, let's say we have $1, it's 33 of currency. So one currency is 0.03 in period, so it's 3 cents, right? It's math round. So using this exchange, we lost 0.0003 of dollar. But what if I send there 0.9 of currency? Then I'll get 0.27 in period, and it rounds back into 0.03 into 3 cents. So we lost some. We won some. We won 1/3 of a cent. If we will try to optimize the value, we will find this. And we win half a cent with every transaction. And in this case, you win, when we convert it back, you win 0.07 of a currency with one round. So the exchange rate is now not 33, but 27.67. So it's a good conversion rate, I think. No, sorry. So if there is no one-time passwords and you have no limit on transactions, so you can make, for example, 1,000 of currency sending one request per 6 seconds, for example, like that. And there are a lot of ugly ways, for example, negative account transactions, amount transactions. There was an ugly way when you transferred more than you had in balance, and other race conditions. So, this one is my favorite. Once upon a time, we had a lot of customers from one region, and they all had product made on framework of one developer. And there were a lot of vulnerabilities there, so just don't, this is ugly. It's always ugly. Okay, let's say you decided to improve the security and implement web application firewall. So the firewall is such an application. It is located between user and the target system. It analyzes the traffic, and it detects attack, and it blocks attack. This is a good story how one of our customers, he had a third-party firewall. We found one vulnerability. Let's say it's Sql Injection. It's not important. And we couldn't exploit it because of the firewall. So we started analyzing it, and we found that there is content header, content type header. It just indicates the server, the type of the resource, and also it has the char set annotation and boundary annotation. So the char set is just the encoding of the body. And it happened that we have found such a char set that was accepted with the application, but the firewall, it just ignored it. And it was fine, but the only problem was that the symbols from this char set, they were from the language of the country that was in a military conflict with our customer's country. And we decided that we need to find out that there is another char set, because other way it looked like a backdoor. So we didn't want to start another war, and we found one. It's IBM TIE. So we submitted it to the customer. Everything went fine. So I have to say great thanks to Thai people. All right, this one is a tale of 3 mysteries, actually. So, first of all, running ahead, I have to say that there was a firewall, but it was integrated into the application, and it was written in PHP. So, we found that there is some parameter, and it looked like there is Sql injection here. But we couldn't exploit something like union select because we were locked by the firewall. So we tried to bypass it, and we found that the multiple string commentary allows us to bypass union and select. But at the same time, if we tried something like into out file, or to select something from information schema, or tables or column name, something like that, we were still locked. So we couldn't understand why we can't bypass it. So this is the first mystery. And the second mystery was that we decided to guess the table, because we couldn't get it from the database. We just guessed it that there was a table users, and there were columns like ID, email, but there was no password field. And there was no such like pass, hash, something like that. It was another mystery. And the third mystery was that there was another Sql injection in cookie, and Web just ignored it. So we managed to upload web shell. We negotiated with the customer the process of downloading source code, so our black box became white box, and we took a look at these riddles. So first of all, we found that there is a firewall inside the application, and that the developer decided to enable check on some obvious words like, for example, union, drop, select, and suddenly shut down for SQL. And if you pay attention, these words, they are surrounded with spaces, or there is only space on the left side. So this is how we can bypass the firewall, because some other markers like table name, information schema, and something like that, they didn't have this space character. So we could bypass union, but we couldn't bypass table name, for example. This was the first riddle. Oops, sorry. Yeah, the third mystery was obvious. There was just no check for cookie. And also, there was such a thing that, for example, when the attack was detected, only then the developer decided to remove these commentaries and replace it with spaces. So not in time, not in time. And the third mystery was that the password field was mopas. I don't speak French. It was mopas. So we considered this as a special French protection that works better than the firewall. All right. So the ugly case. Do you remember the story about that failure firewall? So the developer, he let SQL injection in the firewall. So even if it will work, it will be vulnerable to SQL injection. If you take a look, all parameters, if the attack is detected, they will be serialized and then put into the request without any escaping. So I can say that this is kind of double fail. I've never seen such an ugly case in my life, and just avoid making your own firewalls. All right, so about SQL injection, a couple of words. There was a good case. We found SQL injection, but we couldn't make anything with it. And then we realized that we are getting into link. So we failed, but later I found an article. There's a short link down there. How one guy, he managed to make link injection to remote code execution using some special library in .NET. The bad case here is sending the whole query to the server. It's just bad because even if you are practically sure that this is, let's say, administrator account and everything is fine, there is no, let's say, cross-site request forgery, there are no cross-site scriptings, you can still fail at privileges and there can be exec on your system. And the ugly case, it happened when we found once that there was some site with parameter index, with parameter route and value index, and it worked well. We put a quote there and found that it just drops with 500 error, but one of the vectors with %, it gave us normal output. So we decided that the system is just waiting for something normal, for something determined. So we tried a little more risky vector, and we got something like excess PHP, for example. Then we tried to increase the limit, and we got gateway timeout. So usually when you get gateway timeout after SQL injection, it means real trouble. But not in our case. We increased it again, and we got index PHP. So this is kind of Boolean-based SQL injection. We tried to extract some data from the database, and we found that there was table files. With one of its columns, it was fname, and it just consisted of PHP files. So we tried to read some local file in the system. We managed to do it. So we realized that the logic was something like that. There is a request into the database, and this output is just being included in the script. So we decided to use PHP wrapper to read file contents of source codes. It happened. We analyzed it. We wrote our shell code to session file and managed to remote code execution. So the thing is that even if you are practically sure that there is no Sql injection on your target system, you still have to protect your passwords. Does anyone can tell me the best way of protecting your passwords in the database? Come on. Encryption or hashing? Who says encryption? Who says hashing? And others? Okay. All right. The thing is that let me say that encryption is a good way when you are sure that your target system, when your source code is invulnerable. But if we can manage to find the key and we will get the data from the database, we'll decrypt everything. In this case, hashing is much more better. But if the password policy is weak and even you salt your passwords, then it can be brute forced using the GPU. And also, I have to say that the bad case is absent here, but there are two ugly cases. So the first one is we found a Sql injection. There was table user, and all hashes were hashed in a pretty well way, and the password policy was all right, so we couldn't brute force anything. And then we took a look at another table. There was table user back, and all passwords were put in plain text there. And the other way was when there was cool hashing with great salt, bunch of iterations, but the developer decided just to log all login attempts and to log it into login file inside the web directory. So it's not a good way. Yeah. But I have to say that there is such a hash. It's called Argon2ID. Have anyone heard about this? All right. So the thing is that it was developed to be resistant against GPU attacks and also to be resistant against side channel timing attacks, and it's open source. It has implementations in a lot of languages and even in PHP. So to protect your customer, I just advise you to use this hash. Okay. A couple of cases about arbitrary file upload. The thing is that there were no good cases, so I'll just show you one of the worst. If you'll take a look at code, you will see that there is race condition, there is memory exhaustion, and there is web directory upload. Even two of them would give us remote code execution. And so this library, this class PCLzip, it's just a class to unzip uploaded zip files on the system. And it happens to unzip it into memory. So if there is not enough memory in the system, you can just stop the PHP. So we crafted such a file with shell code in it and a really huge file that was deflated into something small. Then it was inflated back into memory in something huge. PHP dropped, and the shell was still on the target system. This was the tracer script, as we called it. So there was file upload on the system, and I think that you all know that usually when you upload the file, there is special content disposition header, and it contains the name of the file, and then the web server, it will process this name, and it will protect you from directory traversal. But in our case, the developer decided that he should duplicate this name and send it as another parameter. But it was the only one problem. The second problem was that it revealed an error, and in this error we could see not only path to uploads, but also a path to the application. So we uploaded web shell with 2 iterations. All right. Okay. About cross-site scripting, then we could guess if you have some site like this, and no one uses it. But actually, if you are using something like metrics or some advertisements, libraries, third-party plugins, or other scripts, they can be compromised, and you'll get scripting on your site. The bad case was leaving test methods in production. So here you can see that we could just duplicate our input string on the client. And the thing is that it not only bypasses the browser security, but also server security. In this case, it bypasses IaaS systems. And there was an ugly way of disabling built-in security. So here, please take a look at this notation, HTML raw. So the developer ruined the security of that .NET application, just disabling the security. Okay, a couple words about mobile applications, mobile web applications. It happens that really often developers, they think that if there will be traffic from mobile application, from mobile device, then they just can disable all security features, do not validate user inputs, disable captures, start enabling external entities and something like that. So if you analyze mobile web application, you just do it as always as with a casual web application. So now, speaking about mobile applications, first of all, if the device is compromised, the security is compromised also. But speaking about the inner application security of the mobile device, these vulnerabilities, they're really typical and they are kind of not interesting. So I'll just show you a couple of interesting stuff. So this one was just disabling certificate pinning for testing purposes, I guess, and the developer just published this build as a production build. So we could intercept the traffic, and we wondered why is the security feature disabled. Practically the same thing on another project. It verified hosts, and it just returned true. So you know that random thing, that random function that returns 4, this is the same stuff. And this one was tough, actually. So there was some library, and there was a configure, and some domain exceptions were configured for Google Analytics and Google Earth services. So when this happens, we can provide man-in-the-middle attack and use self-signed certificates. And also, the WebView component was configured in a bad way. It allowed JavaScript execution, and it allowed reading local files from the system. And of course, login and password, it was stored in a clean way in some XML file on the system. But also, there was allowed domains restriction, so we couldn't just exploit something like man in the middle, insert the XSS, and then read the file and send it to our server because of this allowed domains restriction. But thankfully, there was this strange replace that created from these domains something like this. So if you see, this is regular expression, and this virtual host like test request google.com will suit this, will match this regular expression. So in this request, we managed to exploit the XSS, man-in-the-middle attack, and get local file reading and send it to our server. So this was a bunch of, this was a huge combination of security flaws. One second. So the boring part, it was there. And now I'll just break the concept of these good, bad, ugly things, because this was a real story. And the human laziness was defeated with echo debugging and a lot of facepalms. So our customer, he just had a component that converts HTML to PDF. It was used, I don't remember, maybe for making e-tickets or for rendering something like income outcome on the system. And for example, there is normal HTML, and this is how it is represented in the browser. The same thing should be visible in the PDF file. And a wise developer, he will just make a special template on the server. He will just make some injection points. He'll receive parameters, escape if there is something that's needed to be escaping, and render the output to us. But in our case, the developer decided to send the raw HTML from client to the server. And this is what happened. But first of all, I just want to debate a little with you. If you know CSS, can you say, is this legal? Will it work? Who says no? Let's see. Okay, everyone agrees. And using CSS, can I read local file? Is it legal? All right. What about this data protocol? It's okay. Yeah, it should work. Yeah. What about FTP? Nope, not only. It will work in Firefox, but it's deprecated in Chrome. I don't think so. Let's check later. This one. No. All right. This one. Absolutely no. So just think, should the developer think it over when he develops this component that creates PDF from the HTML? Or this is a headache of the developer who just uses his component and who receives raw input from the user. So we started analyzing the application. We found that there was a library DOM-PDF, and there was no fingerprint of the version. We Googled a little, there was some vulnerability. We tried the exploit, it failed. So we decided to download the source code, analyze it. And the first vulnerability we found was file and directory enumeration because of improper error handling. So you could send something like image, source, and target to a file. If the file is absent, the error will be image not readable or empty. And if file exists, the error will be like image type unknown. Later on we submitted the vulnerability to DOM-PDF. They closed it, they patched it, so but we managed to find another one vulnerability, and here you can see that there is some CSS, and it has been processed, and using the CSS you can inject new font on the system using the font face annotation. So the application will download the file and put it into the web directory. So, sorry. So it will put in the web directory into some file, and this name is foreseeable. It's just MD5 of the path to the remote file. So this is the exploit, and on the right side in the blob you can see the file name. So we could just access it from the web. But the snag was that in our case, this DOM PDF component was a component of Symfony framework. So it was outside of the web. So we submitted the vulnerability, it was fixed, and we moved on. And we found code injection. So here you can see the attack was possible due to insecure string replacement. So as I've told you, the component, it downloads new phones and it processes them and in a special way to optimize the performance. Then it exports the array with font data and replaces the combination of like single quote, you see this single quote, and real path to the component directory with just global constant name, dot, and a quote. So actually, it replaces it like this. And if you know the real path to this DOM PDF component, you can inject your own code. But you'll say, how we will know this path? First of all, we'll get an error, and we can get an error. We will get the full path to the application, but also, thankfully, to Symfony, this framework has hard-coded value for this parameter. So it was /app//cache. So we got remote code execution on the system. The vector is a bit harder, but I think you got the point. So we're pretty sure that the customer will understand us and will just avoid using this concept of generation HTML from user input. We were wrong. They just changed the component. It was MPDF. I think that a couple of days ago you could read some tweet about how another guy exploited practically the same thing. So MPDF has a special tag. It's called annotation, and if you target a file in href, it will just embed this file into the PDF. So the only thing you need is some vector like this. Then it will be inflated and put into the file. So it will be deflated. So when you inflate it back, you will get the component. But actually, this is not a bug, it's a feature. And we decided to find something really interesting. So get ready to the magic. There was this function, read CSS. And it just makes something like, okay. So it will accept this URL, for example, because it matches this regular expression, and it will download the content of this URL. And also, it will download the content of this URL. It also works in browser, so it's absolutely legal. And then it downloads all those includes. It concatenates them into one variable CSS str. So something like that will be something like this in memory. But the only thing is that they are separated using the space character. So later on, there is such a logic that if there is a URL pattern, URL of image pattern in this variable, it will be decoded, the data of the image, and it will be put into some file. And this file will have foreseeable name, so we can try to guess it, to download it from the web directory, but you have to brute force 10,000 requests, or just get normal output, how we did. And also please keep in mind it's still Symfony, we can't access web directory. So this is our variable CSS str in the memory, and this is how it will be later after the processing. And there's function image that really processes the data from the file. So it accepts really an image. And if you will just read the content of the file, it will fail. But if you will make something like this, that there is a special debug header, and it's legal, and then you concatenate it with, passvd, of course, then you will score. So this is the final exploit. I will explain it now. So this part is the suffix, it's CSS, and the JPEG header in base 64, because it will be decoded later. Then we read the file contents using PHP filter and convert it into base 64, and there is a suffix. So in memory, later on, it will look like this. The prefix, the header, the space, the contents of the file. In this case, I used etc issue because it's smaller, and the suffix, and also spaces. Please take a look at spaces, because how will be the data converted? How will be decoded using the base 64? We just took a look at this function in PHP, and it says that there are two parameters. The first one is data, the second one is strict, and it's set to false by default. So if it's set to true, the function will return false if there are any characters outside of the base 64 alphabet. And if it's false, these characters will be silently discarded. So they are silently discarded. So it converts well. This is the complete HTML exploit. And this is the exploit and the output. So you can see there that there is JPEG header, some stuff, and there is the contents of the file. Okay, so we sent it back to the customer. What do you think the developers decided to do? Of course, please meet HTML to PDF component. So I have to say that this component is based on special TC PDF library, and also this component was written by a French author, as you remember, secure code. So the part of the code was also written in PHP, in French. So let's take a look at this function, read style. It reads inner links as practically as the previous component. Then it gets its content. Then it implodes it using this line break symbol /n. So, and then it just removes this line break character and replaces back with the space. And so we decided, in this library you could specify font family. And for example, if I would specify font family like free mono, it will try to find on the system this free mono PHP. And here you can see that it is already pre-processed. It has some array with some coordinates, just for optimization. So later on, this value of font family, it will be just included. And the problem is that it checks if file exists. So if file is absent, it throws an error, and it's a good error because it stops the application and it shows us the font family. So we decided to make something like this in the memory. This is the exploit. The thing is that it's reversed. I don't remember why. Just don't ask. So this is the footer, the contents of the file, and the header. So this is the request, and that line is the content of the file. But as you can see, in memory, it's camel-cased, and we get it lower-cased. So this really happened because of this function on add font that just lowers this variable. So we decided to extract the contents using double base 64 encode. So this explanation will be tough, but I hope you'll get it. So base 64, it just encodes the data. It takes 3 bytes of the input, and the output is 4 bytes of the base 64 alphabet. So in our case, we don't know the plain text, but we know the chunk that's once encoded and lowercased, and we know the chunk that's 2 times encoded and lowercased. So we will try to take this chunk and we will mutate it using upper and lower case. Then we will decode it back lower and check if it's equal to the chunk that is once encoded. So it looks like this. You take the chunk, you permute it, and if it equals, it's equal. So this is the right name, the right permutation of the chunk. So we edit our exploit a little. Now we can use one-time encoding and double encoding together. So we extract both values in one request. This is just a script, how to extract the contents. And this is the value of the file. So here you can see the output. So we sent it back to the customer. He told his developers, no, of course no. Please meet TC-PDF. This is the library that HTML to PDF was based on. And it's pretty good. But the only thing is that there was some special service tag called TC-PDF. And you can see that if it has it exists, it will just try to decode attributes and call some user function based on that attributes. And so it will be possible only if this constant KTCPDF calls in HTML is set to true. So I think this is pretty secure. But the developer, he decided just to enable this and to warn you that for security reasons, disable this feature if you're printing user HTML content. So we could call user functions from that class. So we found one function, write this cache. It accepts parameters, and so we can make it write anything to any file on the system. Yay! And the other function was add font. You're acquainted already, and it just includes the file. So you write something on the system, you include it, you got remote code execution. So this is the final exploit. These are just the parameters on the system. And this is how it looked in Burp Suite. The code was executed, and later on we found that there was some patch for this thing, that there was some signing of those parameters. But if you know PHP enough, and if you're lucky enough, I think you can try to avoid this this check, this protection. So this is it. This is just a small conclusion of what we found. Of course, every library, it had a server-side request forgery in it, so I just decided not to mention it. If you want, you can make your own contribution to this topic. There are a lot of other projects that convert HTML to PDF. Also, I want to thank all my colleagues. For security reasons, the names are hidden. And thanks for your attention. If you have any questions, you're welcome.
So, for every question, each participant will get one t-shirt. So, who has a question?
Hey, so a quick question, or maybe just a statement about the banking software. There's a pretty well-known attack that happened in Romania 6 years ago with the math round. when exchanging currency from one account to another, exactly as you specified, only the bank had the one-time password implemented. And there's one guy in Romania, Adrian Furtuno, that built a robot and
Yeah, I read about it.
Yeah. I just wanted to say that.
Thank you. Great statement.
By the way, cool finding to the PDF libraries.
Thank you very much. All right. Any other questions? Please.
Yeah, so the question is, you talked about, so you talked about the fact that in certain cases, any file, basically your exploit could write files into the systems. Wouldn't this kind of exploit be avoided if the process under which the application works would just be, you know, locked from a security point of view, or somehow, you know, put in a virtual machine or in a container?
Look, in this way, there is always a temp directory that is allowed to, it's usually allows to write everything for every user. And I also heard that there is such a way of writing into file descriptor. There will be a research in a couple of weeks, the disclosure of this. So I think that anyway, the problem was to call user functions, and the problem was to allow even just using this tag, because that function write this cache, it was okay. Actually, it was designed to make this. So if you will just restrict writing to every directory in the system, I think that it will work, but there will be no such a point. So, thank you for the question. It's kind of over-securing, over-reacting in this case. So you have to protect it a bit before.
I'm the next question. Thanks, it was very interesting. Regarding SQL injection, you mentioned about vulnerability in link queue. I didn't understand if it is present or not.
It is present for link library 1.0.6 version. When that guy, I don't remember the name, he made it to remote code execution. And now it's 1.0.7. So if you are up to date, there will not be this issue.
Yes, I use quite a lot entity framework and link queue, and that's why I asked. And in general, it shouldn't be used like this to form a query from strings. There are libraries to use classes for parameters and keywords. That's why SQL injection is so largely found, I guess.
Yeah, but if it was HQL injection, for example, it will be a bit of more harder issue, I guess, because sometimes you can make SQL injection from Hibernate, and sometimes you can make it to remote code execution. Thank you for the question.
Based on that functions, can we put some restrictions on some functions that if somebody is trying to access some files, maybe some databases can be stopped? I mean, a function from somebody from another country?
I think that it's possible, but again, it's overreacting. in this case, because you kind of have to protect it before calling any function on the system, before making those restrictions. If I understood you right. Okay, thank you.
I think this is more of a reaction than a question, but it's actually a question if you can explain the how the last bank actually handled what you discovered, because to me it makes no sense. Like, they had the library, you discover vulnerabilities, right? Like, if those vulnerabilities were patched, why did they change the library? Like, why did they migrate to a new one? And after they've done that like 3 or 4 times, like, why didn't they stop and kind of take a step back? Like, it makes no sense to me. Why wouldn't they like cut the feature or kind of, because I think you've also given them advice to like sanitize the input,
sure.
right? Why didn't they follow that advice? Like, it makes no sense.
I think that this is because of kind of nowadays bureaucracy development. When you have to test it, when you have some steps, a lot of steps to test the product before the production, and so they decided to go in the easiest way, not even patch the front end, just change the component. So on the 4th issue, they finally started sending parameters in a good way, but I think that for them it was much easier to change the component, and also they were not waiting for example, DOM PDF vendor, because they just change the component and it's okay, because maybe if it's vulnerable to this, it is vulnerable to some other stuff, so just let's change the component. Why not? Okay, thank you very much.
So you talked about the SMS two-factor authentication, that you can duplicate SIMs and all that. There's a bank now. There's ING, which uses like a user. There's a user code, and there's a 5-number password, and there's a 2FA, and you can do everything with that. Ain't that a bit shallow from what you've seen? Like,
sorry, could you repeat the last phrase?
Okay, so the username is like a code, which kind of can be defined. It's like your first 2 letters of your first name and the 7-letter code. That's the username, and then the password is like a 5-digit number. And then there's the second factor, the authentication by SMS.
6 digit?
Yeah.
Okay.
I think it's 5 though. Yeah, it's 5. So ain't that a bit too shallow?
I don't know. I think that we will see if they will get some money out.
Also, I think we have bigger issues than that, and you know what? Like keeping databases in Microsoft Access.
You know, it's always a tricky question for banking to implement more security or to make it more comfortable for a user to use the banking. So, you know, this comfort, security. Yeah. New question again.
Just a remark, at some point they actually had like secure tokens, and then when they migrated to SMS, they had the SMS be free and the tokens paid. So like that also doesn't really make sense.
Right. Okay, so no more questions?